Hello and a warm welcome back. Today on the bench, hopefully for the freaking last time, is the left hand side power amplifier, which I'd already fixed, and it's taken a very long time to get here. I replaced the 2SA8800, which I think was responsible for all the noise on the left hand side one, which is this one, with two SA8800 individual transistors with the emitters common, and then these were matched. I first matched them on my little simple tester, and then I made up a simple differential pair on my breadboard. I've just done some quick testing, and what have I done? I've tested 1, 2, 3, 4, 5, 6, 7. Tested 7 transistors. They're mostly in the 400 sort of area, HFE of about a 400. After testing for HFE on that very simple little tester, I built this little circuit here, and I'll show you the schematic in a minute. And you know, it should, in theory, match two transistors pretty damn good. Let's have a look at the schematic. Because I'm used to using constant current sink sources in valve amplifiers, this was reasonably easy to figure out. So what we've got a light emitting diode for our voltage reference, and then we've got an emitter resistor here. So what we've got here, this transistor here, badly drawn, is a 2N2906A, I think. That's our emitter resistor. That sets the current going through this transistor. That is then connected to our differential pair. Again, I'm used to this because we use a long tail pair, which is the same thing as a differential pair in valve amplifiers. To try and get as accurate results as possible, I use 1% resistors here. So we've got a couple of 10Ks going from the negative rail to the bases. That should set the bases at, I don't know, 0 volts ish. Then I've got our two 1K resistors here going to our collectors, and I'm reading the voltage across those. If they are the same or within 5% of each other, then we know that those two transistors are matched. Let's have a look at our actual results. So this is the left hand transistor, right hand transistor. This is reading in millivolts. So we've got 183 millivolts here, and 197, let's call it 198 millivolts. I haven't done the maths, but I would say that they are within 5% of each other. They're not that far off. What, they're about 10 millivolts between them, so maybe not. So when I did this, the results I got were a lot better. The ones that I put in to the amplifier worked fine and got rid of the noise issue. Right, let's crack on. After matching the KSA992s to replace the 2SA798s, I put some rubber heat shrink around them with some you know, the thermal compound in there, and bonded them all together. Tested the amplifier. I'm going to zoom you out because it's not what's in. Focus in. Tested the amplifier, and the noise had gone on the left hand channel. However, I still had a problem. It kept going into oscillation and all the rest of it. And while all this is going off, I had this left hand model out, completely out, after taking all the wires off the bottom, all the connecting wires, and then testing it on the bench. Next, I was in two minds whether to replace these drivers, which you can see in front of you here, but because they're in such a crap state with all this black oxide coating on them, which isn't factory, I decided to replace them. Right, replaced the two drivers with the MGE 150 30 31 Gs. They check out DC conditions wise, but we've got some high frequency oscillation that looks to be at about, let's say that's about 2 divs, blah blah blah, that's about 1 volt oscillation. I'm putting that down just at the moment to the fact that the amplifier module is out. I'm going to put it back in and then see what the crack is, because this is not an ideal setup. Oh, and DC offset is okay. I mean, it could be better. The left hand amplifier module is back in the amp. However, I didn't have the bias set correctly, so that's what I'm going to do now. So what you do on the power, the pre-power out on the back there, those two that big jumper, on the power in you put a RCA phono jack with a 5K1 resistor across it. I haven't got a 5K1 resistor, however I had got a 10K precision pot, so I set it to 5.1K. I have me meter probes on pins 3 and 9. These are our output transistors, and before I did all that I set the preset fully clockwise, meaning that it's reading 100 ohms. I made sure of that, and therefore right there 33 volts, 30 millivolts. So now you have to wait 30 minutes and then come back and do it again, adjust it again. Half hour later, one coffee later, it's gone up to 43. Here we are the next morning. Just turned the amp on. When it turned it on, it was 29 millivolts, and now we've got 33, and it's creeping up. This offset, I mean the bias voltage, is a little bit puzzling. So what I'm going to do, I'm going to leave that on for a bit, sort of a bit of a soak test for quite a few hours, and just keep an eye on it. And then in the meantime I'm going to go and study the schematic, try and understand it better. I'm really not very good at this framing, am I? Try and understand it better and have a word with the boffins. It took me a while to understand this bias circuit, but essentially if you think about it in terms of just like a voltage or a potential divider, then it makes more sense. So what we have here, we have a positive voltage at the top, negative voltage at the bottom, and then we have this transistor here, Q4. Let's think of it as a transistor, and let's think of it as just a variable resistor, like a pot potentiometer, yeah? And then we have VR1, which is our preset, which sets the actual voltage current going to these output devices. We've got D4 and then we've got D3. D3 is a custom package with 3 diodes in it to make a bigger voltage drop between here and D4's cathode. With me so far? So what happens is current flows through Q4, through the preset, through D4, through D3, etc., and then to the negative rail. So we've got current flowing through there. So at first the boffins suggested that I replace these 160 ohm resistors here, which is Q4's base and emitter resistors with something bigger like 180R. If in theory we did that, then less current will flow through this diode chain in the preset and all that, and then that would mean that we've got less voltage between here and here. As you can see, I hope you can see, we've got 1.2 volts here, and although you can't sort of see it, there's minus 1.2 volts there. So in total that is a voltage of 2.4 volts. So what we had before, and what I couldn't understand, was the less that I made VR1, like lower and lower ohms, then I would get more current and the output transistors will get hotter. But as I said, if you think about it in terms of a voltage divider, you get a little bit of voltage dropped across this preset, a little bit voltage dropped across this D4, and a bit more voltage dropped across D3. So as mentioned, tried reducing the current going through. It improved things but didn't work. So in the end, thinking about it in the wee hours of the morning, as you do, I thought, what about if we make D4 a different diode and make the voltage drop across here between the preset and D3 smaller? Then that will reduce the voltage here and here, and thus the current flowing through these driver transistors. You see, this was the problem. By replacing Q5 and Q6 with different driver transistors, they had different DC operating conditions, and this is why the need to change all this McGubbins here. To cut to the chase, what I did, I changed D4 for a Schottky diode. For those of you who don't know, a Schottky diode has a lower forward voltage drop than your normal transistor, than your normal diode. D4 being a sort of bog standard silicon diode has a voltage drop, let's say, of about 0.4 volt. The Schottky diode that I put in there had a voltage drop of about 0.2. Thus, like, the voltage across here was dropped and everything was good. Hope that made sense. Now I'm working on the right hand side power amplifier board. I've replaced the two SA798 with two KSA992s, thermally bonded and matched. That's just a bit of heat shrink with a little bit of heat compound in there. I've replaced the two drivers, same as with the previous power amp. The fit going into these is not brilliant. Yeah, so I'm going to have to do the same there. Clean up all the heatsink, which I've already done on the... Yes, I've already cleaned up the heatsink. This time, instead of using mica, which split a lot, I'm going to try using some plastic sheet. I've got various offcuts that I've kept over the years for that. We'll try that. Last thing I've got to do, I've already replaced the capacitors. Oh, it's got heat shrink compound on it. Gets everywhere. So the last thing I'm going to do is just replace this preset. I did the same as what I did with the other one. Unfortunately, I didn't make such a good job on this one. It's a bit crap. I mean, electrically it's fine, but yeah, it doesn't look very good, but hey ho. Right, I'll crack on with that. Well, finally, after what seems like days, I've got the right hand side power amplifier module working okay. Just knock this down, just adjusting as I go. I'm just trying to think, which way do we go? There we go. Yeah, it's working okay. Originally, when I tested it after replacing the capacitors and the input to SA8800 and the drivers, it was reading about 30 volts on the speaker output, and everything, the DC conditions were all over the shop. And I looked and looked and looked, couldn't find it. In the end, it was because the soldering on the two transistors down there, the common emitters, I hadn't quite got it soldered properly. Soldered that properly, everything worked okay. And that's one done. Left hand side done. Come on, down you come, baby. This is the beauty of having these Cermet 25 turn jobby pots, presets, as I say. There. It's gonna go up a bit, but fucking hell, doesn't matter. Right, however, we are still not out the woods. I just tried it previously and there wasn't any output from either channel. Why that is, I do not know. I shall investigate further, and I still have a inkling that this bloody protection circuit is messing me about. However, I've been studying that, so we're going to do, after I've checked the offset and made sure that the other two pairs of output transistors are also reading 30 millivolts, check the offset, I shall tackle the protection and also have a look at why we aren't getting any output. It never fucking ends, it really never ends. So as you can see, one of the output devices is missing, and that was a very simple slip of my probe when I was testing bias, slipped and it killed one of the two SB617As, which are unobtainium. However, I can get them, they're just a lot of money and there's a minimum order of 50 quid. So in the meantime, what I've done, I've replaced it for a 2SA1265. I can't remember what that says. Is that an N on there? And as far as I can tell, that is the same spec, i.e. 70 watt dissipation, the same bias conditions and all the rest of it. So I've got to test that out now and see if that works. I was really gutted when I did that, because I mean, like I say, these things are unobtainium and it's a damn shame, but these things happen. If you've ever worked on transistor amplifiers, you will know that it's very easy to slip with a probe and kill things, especially in a DC coupled amplifier like that. In fact, I was really lucky it didn't kill all of these or any of the other transistors. So where are we? I was here. This amp was basically should have been finished about a week ago, but I've had so many setbacks and fucking irritating things. One of them being is when you come to take the transistors out, they're folded over onto the pads and they are a nightmare to get out. And let's see if that replacement output transistor works. That's the left channel. I am going directly into the power amp inputs, as it were. So we've got a lovely sine wave out. I have a look at the right side. On the right side we have Sweet FA. I don't know, as you can see in there. So if I go here, this is our right in. I'm getting a sine wave on the scope. Right, that green wire then goes from there into the ampere, getting the sine wave on the scope. Then there's a trace, goes over to a coupling capacitor, and I'm not getting a sine wave. So from that I concur that the trace is damaged, and I've had this a few times on this amplifier, because the problem is when you're taking the bugger in and out, no matter how careful you are, the traces can get damaged. And I mean, I can't see that that's damaged, but it obviously is. So here we go again, 2, 3, 4, fun and games. Right, so this is the output on the right hand side. Loads of oodles of output. This is the output on the left hand side, not oodles of output. This is one of the going into the bases of one of the output devices on the right hand side, oodles. This is the same on the left hand side, not oodles. So from that we can concur that there's something wrong with our, I'm just messing around with it pre-whatnot. So okay, we need to go further back, and this is working fine the other freaking day. I've got fed up with having the amp working one day, coming in the next day to test it and put it all back together, and it not working. So the problem is there are 16 switches in total in the signal path. 16, for fuck's sake. So if we look at the faceplate just to get an idea, we can discount the speakers AB and everything, well, just for now. You've got high and low filter, so that's, you know, 2 switches there. Loudness, muting. We've got this tape, 2 tape switches here for sending your program material to tape 1, tape 2, etc. Got this switch here, another switch here, yeah, switches everywhere in. What this amp needs, if the owner intends to use the switches, front panel off and get all the switches off and put them in an ultrasonic cleaner and then re-lubricate them, etc. I'm not set up to do that, and I've already put a lot I've already put a hell of a lot of time into this amp, and yeah, I'm not doing the switches, no way Jose. So that's what we're going to do, just jumper that out and it works a treat. I am now hopefully gonna soak test it for the next, I don't know, few hours, see how we go, and before I finally do put it back together, I'm just going to see how the protection circuit operates in that time, and if it's still being a little bit finicky, I might change some of the transistors out. Well, as you can hear, I've got it on test again, and for the last couple of hours it's working okay. Let me turn this off. So yesterday I put this jumper in, you know, jumper these switches out here, working okay. Turned it on this morning to make 100% sure it was working, and the protection circuit wasn't engaging. So I spent all morning taking DC conditions and trying to fault find the protection circuit. I found that Q3 and especially Q4 looked a bit suspect, so I replaced them again with the same transistors that I used in the control amplifier, namely 2SA8800, mainly because they got the same pin out. So I think it's working. Mind you, I've been here and said that, I would say about 75 times or something like that. So what I'm going to do is get my extension out of the shed, because this runs on 100 volts, take this into the living room and test it on my speakers and just run it for the day and see how we go. Turn the volume up. Woke up this morning and I laid back my head. Yeah, still got scratchy switches.
All that you said, all your looking is
Don't know if you can hear that.
what do we find? Honey.
Yeah, that didn't sound too bad, did it? Right, I'm just going to put one of the records on that the owner left me as a test record. Brian Porter or somebody. Oh.
Listen and gather round me, children, children of a mother whose life lifted up. Listen and gather round me, children, children of a mother whose life lifted up peace. A mother who taught all of her children to love and be loved.
Yeah, not really my bag, but there you go, Ambrose. All working, me old duck. So these are all the components that came out that needed replacing. Lots of capacitors and the transistors. In actual fact, really, this amplifier could do with more of the small signal transistors replacing, even though all of these transistors here test good. I'm pretty damn sure that they're leaky, which has caused me immense, trouble, because leaky transistors are sort of tend to present themselves in an intermittent fashion, working 1 minute, not the next. Lastly, as regards fixing vintage amps, one of the other major problems I've had is just finding data on the old components used in these amplifiers, and also the amount of time it's taken to search online to find replacements. This is the problem with vintage amplifiers, is all of these transistors are well obsolete, and some of them aren't too bad. They're pretty standard jelly bean sort of amplifiers. However, especially on these Japanese amplifiers, the pinout, because they're like 2SA and 2SC and everything, which goes ECB in pinout, then you have to find a transistor with that same pinout. For instance, like some of these small signal transistors here, I could have used like a BC 550, 546 or something like that. However, that would have meant sort of struggling to get the things into the PCB. This situation is only going to get worse, because having looked at quite a few sources online where people have repaired these, say in 2015, only 10 years ago, the replacements that they advise are also no longer made and obsolete. And as electronics advances, manufacturers aren't making a lot of these sort of capacitors and transistors anymore. It's all power electronics and SMD stuff. So yeah, it's only going to get harder. So think on before buying a vintage amplifier is my advice. And with that, I'm going to get back onto valve amplification soon. I mean, we're going to have the same problem there with valves. I just found out that one of the major valve suppliers in the UK is just shutting up shop, Bellington Export. They were, they had a massive stock of valves, no longer. So yeah, vintage amplification, a lot of these valves you know, are running out, so it is a problem. So yep, next back onto the valve amplification, and after I've finished this amplifier I want to get into using valves more and just build some sort of project for fun. For instance, I've got sort of some bits and pieces for a tape delay. I'd like to have an experiment with that, and the same with some of my some of the other bigger valves I've got, EHT valves, mercury rectifiers and things of that nature. And lastly, apologies for not posting anything for a while. I've really not been very well, various reasons, but I've just had 2 viruses, one after the other, and I'm still in not very good fettle. It's taken me sort of all my effort just to get through the day, never mind about working on, you know, electronics and things. Right, that's me done rabbiting. Thank you all very much for watching. Take care of yourselves. Ta-da for now.